Hello Year 11 Mathematics Advanced students. Today we're continuing on with the topic of functions and we're learning about axis of symmetry. So the axis of symmetry of a parabola is what we're looking at today. So the axis of symmetry of a parabola with the equation y equals ax squared plus bx plus c is the vertical line with the equation x equals negative b over 2a. Like so. The turning point of a parabola, which we talked about a little bit last lesson, is when the quadratic function y equals ax squared plus bx plus c has a minimum value of a is greater than 0 and a maximum value if a is less than 0. The minimum or maximum value of the quadratic equation is the function when negative b minus 2a is substituted into the function. So the turning point or vertex of the parabola is the coordinates negative b over 2a and the function of negative b over 2a. So let's have a look at some examples. We want to find the equation of the axis of symmetry and the minimum value of the quadratic function y equals x squared minus 5x plus 1. So first we're going to look at finding the axis of symmetry. And how we do this is using that equation, x equals minus b over 2a, where what we have is, we have from our equation y equals x squared minus 5x plus 1, we have a equals 1 and b equals minus 5. So let's substitute them in. So we'll have x equals negative minus 5 over 2 times 1, so that just equals 5 over 2, which is 2.5. And then, so we're at therefore axis, oops, that's a horrible S, of symmetry is the line x equals 2.5. And then, so we found the axis of symmetry, the equation. Now we need to find the minimum value. So the reason it's a minimum is because our a is positive, so it's greater than 0. So to find our minimum value, we will sub in our x equals negative a half, or x equals 2.5 into our equation. So into f of x, so we'll have f of 2.5 equals 2.5 squared minus 5 times 2.5 plus 1, and when we put that into our calculator we get 25 on 4 minus 25 on 2 plus 1, which equals minus 5.25. So our minimum value is negative 5.25. So we have answered that question. Example 2, we want to find the equation of the axis of symmetry and the maximum value and the turning point of the quadratic function y equals negative 3x squared plus x minus 5. So our axis of symmetry, we substitute our values into x equals minus b onto a, where if we look at our equation, we have a equals negative 3 and b equals 1. So we'll have x equals negative 1 over 2 times minus 3. So our axis of symmetry is going to be 1 over 6. Therefore, axis of symmetry is the line x equals 1/6. So then the reason it's a maximum value is because our a is negative, so our coefficient of x squared is negative. So we want to find the maximum value, And so how we find the maximum value is we sub x equals a sixth into our function. So we'll have our function equals -3 times a sixth squared plus a sixth minus 5. So that will equal -a twelfth plus a sixth minus 5, which equals -4 and 11 twelfths. So therefore the turning point, or our vertex, equals our point, so our x value, so our 1/6, so our axis of symmetry, and then this value that we have subbed in and found, so our maximum value. And that is the answer to finding the equation of the axis of symmetry and the maximum value and the turning point. Example 3 is to determine whether each function is even. So if we reflect back a couple of lessons, we remember to find out if a function is even, we have to substitute in a negative x. So for our equation, we're going to say f of -x equals, and we substitute this in, and we want to get the same function back. So when we sub in -x into our first function of fx equals x squared plus 7, we get f of -x equals -x squared plus 7, and anything negative squared is just a positive, so it'll be x squared plus 7, and this equals exactly what our function started with. So because it equals the same thing, it's even. Okay, so if we can, when we sub in a negative for x, if we can get back to what the function started with, it's always even. And then for b, we want to determine whether the function is even, and we have g of x equals -x squared plus 8x. So if we sub in a negative x where we have x, so negative times negative x squared, negative x squared is just x squared, plus 8 times negative x is -8x. So this is -x squared minus 8x, which is not the function. So therefore not even. So if you're following from the Maths in Focus textbooks, if you're in advanced, you would now have a look at doing exercise 309, and if you're in extension 1 and using the extension 1 textbook, you would do exercise 4.